Welcome. I am so excited to be here, and welcome to Mechanical Engineering's Discovery Day. This is something totally new to us, so we are asking for your patience. There's a lot of technology behind the scenes here. So the first thing I ask that you all do is please mute your mics. In addition, it would be good if you turn off your video feed as well, so you can just watch the team's tour we're going to have for you. We'll have plenty of time later at the end of this for questions and answers. We'll explain how to do that. We're going to show you a series of destination sites where you'll learn a lot about what we have to offer in mechanical engineering for our students. You'll get to meet some of our current students, and you'll also get to meet some of our faculty. It should be quite a fun event. So let's get started. Let me introduce myself. Michelle Klaus, the chair of mechanical engineering, and behind the phone camera is Eric Anderson. Eric Barty. He's our assistant chair.
Hi, nice to meet you all.
Let's go. Go ahead in, Eric. Okay, here in our lobby is another one of our helpers, Ethan. He's helping behind the scenes. This lobby is really a very popular site for our students. The students get to mingle, they get to build community, they get to work on homework and collaborative projects. It's usually hustling and bustling in here. And I also want to point out that banner up there, mechanical and electrical engineering, here at Grove City is in the top 100 undergrad programs reported by US News and World Report. Our first destination is going to be just down the hall here. But as you go passing through this hall, see there's a couple things to note. On the walls are lots of posters, and these posters are associated with different capstone projects we've had, as well as research. You'll see them in all the halls that we travel through. So on to our first destination. At this stop, you get to hear about some student organizations, and we have some representatives here. So let's go in. Hope's going to be our first student. She's a senior mechanical engineer and newly elected homecoming queen. Yay! She's going to tell you a little bit about ASHRAE.
I am the president of ASHRAE, and I'm a senior mechanical engineering major here. I have been involved in ASHRAE since my freshman year. It is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. So basically, if you like hockey, if you like to swim, HVAC is there. We have scholarship opportunities. That is one of our biggest draws for students. I was a recipient of a $5,000 national scholarship my freshman year, so it is achievable. We have tours to different Pittsburgh facilities. Granted, right now, COVID's kind of messed up our plans. We also have good professional connections, and that's helping a lot of us to get careers in the HVAC field. So we hope that you join ASHRAE.
All right, our next student here is Sarah Walker. She's going to tell you a little bit about Society of Women Engineers.
Hello, I'm a senior mechanical engineering student. I'm with the Society of Women Engineers, or SWE. Here on campus, our main goals for SWE are professional development and fellowship with other women in STEM. Now, it's not limited to only females. Males are welcome to join also. We do a variety of events throughout the semester, including mentorship opportunities, student internship, and alumni talks. A spaghetti dinner with our professors, baking, just something to do that's relaxing. We have trivia and movie nights, and we've had a professional makeup night. It's part of a larger worldwide society with over 42,000 members. The National Society advocates for women in engineering and technology, just like we do. But that provides networking and resources, including a quarterly magazine that if you're interested, you can join us here.
Our final student in this area is Sam, and he too is a senior, and he's representing ASME. Go for it, Sam.
Thank you, Dr. Klaus. Hi, as Dr. Klaus said, my name is Sam. I'm the president of the American Society of Mechanical Engineers chapter here on campus. The American Society of Mechanical Engineers, we call it ASME, is the professional organization for mechanical engineers in the United States. And that's really what ASME tries to do here on campus, is that you'll be learning a lot of technical skills in the classroom. But what ASME focuses on is the professional aspect of engineering. And we show that through service projects and educational events outside the classroom. Some of the things we'll do is that we'll hold workshops, whether that's with welding or otherwise, for people in the Grove community. We'll do litter cleanups around the Grove City College campus. And we usually have a speaker. We have speakers come in what we call our Nike X Talks, where a professor or an outside speaker will come in and talk about some of the research or professional experiences. Also, what's fun is that we have a Christmas party at the end of the fall semester every year. Sometimes the president comes by and reads Christmas stories, so I would not miss that. And we also sell ornaments that we make in the Grove City College Mechanical Engineering shop. So really what ASME is all about is just building up those professional skills and experiences for you as you grow into your professional development as a mechanical engineer.
Thank you so much, Sam. You're going to also get to meet some students that are involved in SAE later on when we talk to you about the Baja Team. So thank you all, Sarah and Hope and Sam. And Eric is going to take over and introduce our next stop, which is going to be our next technical adventure. Go for it, Eric.
Hello, thank you, Dr. Klaus. Again, this is Dr. Barty, and our next feature that we're going to go ahead and look at is our minors. We have a minor in robotics and chemical engineering, and our very own Dr. Allison, who is not able to make this event, pre-recorded a video that we are now going to go ahead and play for you to highlight some of the details surrounding those minors.
Hello, my name is Blair Allison. I'm a professor of mechanical engineering at Grove City College. Thank you for coming to our virtual STEM Discovery Day. I'd like to talk to you for a few minutes about mechanical engineering related minors. Specifically, I want to talk about chemical engineering minor and a robotics minor. First, let's take a look at the long list of minors that are available at Grove City College, covering many different areas. These are all listed in the Grove City College Bulletin that you have access on the college website. I'm going to talk specifically about the two that are highlighted, the chemical engineering minor and the robotics minor. So what's a chemical engineering minor all about? Well, it's the combination of chemistry and engineering. More specifically, the definition here is, I think, a good one for chemical engineering. If you're going to work as a chemical engineer, you're going to work in a branch of engineering that deals with production of chemicals and the manufacture of products, and this is through chemical processes. So a chemical engineer might find himself or herself designing equipment, designing systems and processes, and this would be for the refining of raw materials, for maybe mixing and compounding and processing chemicals, with the goal of making valuable products or very useful products. At Grove City College, the chemical engineering minor requires you to take 19 credit hours of courses, and they're listed here. The first three, chemical engineering fundamentals, separation processes, and chemical reaction engineering, those courses were developed specifically for the chemical engineering minor. The four listed below, thermodynamics, fluid mechanics, heat transfer, and a thermal fluids laboratory, those are required mechanical engineering courses that all mechanical engineering students would take. So if you were interested in obtaining a chemical engineering minor, you would need to take only 3 courses above and beyond the standard required classes to obtain a bachelor's degree in mechanical engineering. Let me say a few words about a robotics minor. First, let me talk about 2 main types of robots. One we would characterize as industrial robots that get used in manufacturing situations often, anything from handling large heavy parts to high-speed material handling to welding applications, painting. And the robots that you see here were developed by a company called Fanuc, and these are in wide use in the United States and around the world. We have a Fanuc Robot, the one that I've highlighted in the top middle of this illustration, and I'll show you a little bit more about that in a minute. The other main category of robots are mobile robots. The one shown on the left is one that was designed, built, tested, and sold by Boston Dynamics. This robot can walk, it can run, it can jump. In fact, it can even do flips. The other robots, the bottom right, this is a robot that might typically be used by, let's say, a bomb squad, controlled remotely. It can be moved into position. There are cameras that can examine something that you're approaching, and there are arms that can move things around. The illustration in the upper right is a picture from an Amazon warehouse. The units that you see in the front here are used to pick up shelf units at some point in the warehouse, bring it to a location where a person would, pick out items to make up your order. This shows you the two robots that we have in Hoyt Hall to support the Robotics Minor. These focus on the industrial robots. The two illustrations that you see on the left show a Fanuc LR-Mate 200 robot that has been integrated into the cart that you see on the left. Fanuc calls that their Certified Education Robot Training Cart. And we have one of those that's used in our industrial robots lab. The illustration on the far right is a 4 degree of freedom Quanzer Canova robot, and it's used by the students to help them better understand things like forward and inverse kinematics and trajectory planning. This helps them understand what goes on behind the scenes in terms of the mathematical calculations that are needed to move a robot in along a desired trajectory. The courses that you need to take to complete a minor in robotics are shown here. 20 credit hours are required. The 3 courses at the top, mobile robots, industrial robots, and ethics in engineering and robotics. Those 3 courses were specifically developed for the robotics minor. The courses shown below are either required or elective mechanical engineering courses. That includes system dynamics, control systems, kinematics and dynamics of machinery, or you could also take introduction to mechatronics. And then all students have to complete a 4 credit hour robotics related capstone design project. I should mention that in the industrial robots class, students all have a copy of robot simulation software from this company Fanuc. And with that simulation software, they can simulate the same robot that we have in the lab, the actual robot. They can program it. You see a teach pendant shown on the right here. And they can develop programs, test them out here, see the robot moving, and then you can transfer those programs to the actual real robot. So having the virtual robot on their computers allows students to get a lot more practice at developing programs and becoming more and more familiar with that particular robot. Thank you for being part of this today. If you have any additional questions related to minors available within the mechanical engineering department, please get in touch with anyone in the department. And also, if you have any questions at all about mechanical engineering, please contact us. We'd be happy to help you and answer your questions. Thank you for being part of this today.
Our next destination here is going to be where you're going to learn a little bit about our capstone projects. You'll find out that this is probably the highlight of the 4 years. All the students their senior year are part of a capstone group. And our capstone coordinator is Dr. Vern Ulrich, and he is going to tell you all about capstone at Grove City College. Vern.
In 2 minutes or less. In fact, I'm going to take this off so you can hear me a little bit better. But anyway, I want to welcome you to the Senior Design Lab. And there's actually one of two rooms we do this in, and it's a room that becomes kind of whatever the seniors would like it to be every year. There's some opportunity for meeting tables, and there's opportunity to work on projects, and we do have a couple of students in here. We're going to talk a little bit about their projects. But in addition to that, I just want to tell you that here at Grove City College, we require you to do a full 1 year senior project. Okay, and usually that involves doing design work in the fall and building things in the spring. There's a variety of projects we do. In fact, one of my goals as sort of a project coordinator here is to find a variety of projects that can be hopefully maybe a stepping stone from you to get to a job that you'd like to find. It's one of the reasons why we do sometimes things like HVAC projects or you know, a Baja car project could be a stepping stone into a capstone or into a job with the automotive industry. We also have a number of local industries that sponsor projects here, and we have the opportunity also with them to perhaps get some employment, maybe an internship, those kinds of things. And also the opportunity to have some sponsorship and some interaction with real world engineers in the process. My goal really is for it to be a real world engineering experience for you that you can then translate into something that's useful down the road. With that, I think I'm going to let some of the students talk a little bit.
Perfect. Our first student is going to be Josiah, and he's going to talk to you a little bit about a project that we have going on in conjunction with ENSCO Rail. Josiah, please.
Okay, I'm Josiah Ellis. I'm a senior Mechie here at Grove City. And first I want to start with, we're picking up this project from last year's ENSCO group with COVID hit. They had the job off at the end. And just going off of Dr. Ulrich, the team leader from ENSCO's team last year actually is working with ENSCO now. So it's a great opportunity to get some experience with the company and possibly get a job, just like Dr. Ulrich said. So our project is with ENSCO Rail. They do technology and solutions for railroad systems. So what we want to do here is, here's like kind of an example of the system here. We want to apply a 2,000-pound lateral force against the rails. We're doing this because when there's force applied and the rail moves, a train could possibly derail. So we need to figure out how to make this force be applied laterally to the rails. So our idea is to use a hydraulic piston, which is right here. We're going to put this in the middle of our axle here to apply the force. Now, some things we need to do that. We need to make a control system. We're going to have a force cell that reads the force, relays it back to our computer, which collects the data, and then changes pressure in the hydraulic cylinder. So that's pretty much the basis of our project.
Thank you, Josiah.
Dr.
The next student that we're going to be talking with is Andrew. And Andrew is involved with the BPMI project here that we're having. And so he's going to tell you a little bit about that. And we'll peer into the location at the end of our discussion so you can actually see the station. Right now, the electrical engineering chair is in there talking. Okay, Andrew, go for it.
So to start, BPMI wanted the school to build a valve testing rig to test a valve and cycle it for a specified amount of times and be able to read the torque off of that. So this year, we just ordered a torque sensor to fit on the shaft. And along with that comes having to manufacture a base plate, and we have to order couplings and bearing blocks and bearings so that way no loads interfere with the torque sensor. That's currently what we're doing right now. We're also trying to make the valve adjustable in size. So we made a sleeve that works as a coupling to basically be able to test any size valve that you want. And we're going to go see the rig right now. This is from the mechanical side. This is the shaft, and the valve hooks onto there, and then that cycles the valve from open to close. And we're going to fit a torque sensor in here, possibly with another cage, and then we're going to have bearing blocks and couplings all in the shaft as well. And on the back side is PLC HMI. So this is how the torque sensor communicates with the user, so that way they can see what's going on. and it has a bunch of emergency stop functions. We're working on currently another one. And that's really it.
All right. Well, thank you,
All right.
Andrew.
Right. Andrew, thank you so much. And thank you also, Dr. Ulrich and Josiah. Have a great day. And Dr. Barty is going to tell us about our next series of destinations. Sir?
Great. All right, Dr. Klaus, thank you very much. Next stop, we're going to go ahead and take a little visit to what we call our junior lab. So it's going to take a minute to talk about this, and then I'll turn the camera around to showcase a few pieces of equipment that we have here. So we have a course called Junior Lab, which is a standalone class, takes place in the fall and also the spring semester of the junior year. In the fall semester, the class is based on what we would call instrumentation. So as an example of what we do, I'm going to go ahead and focus in on one of the experiments that's currently set up. So here's one experiment that students just completed. This is a steel beam suspended by a string. And what we do is that we attach an accelerometer to it. And the accelerometer picks up the vibrational response. And there's a series of equipment such as signal filters and amplifiers to collect that data and then to convert it into a form where you can actually detect the frequencies that are that the beam is vibrating at. And then what students are required to do is write a technical report about that, for which we go through a few drafts in order to give students what we would call an experience in writing, because this course is what we would designate as writing intensive. And then the spring semester, the course is basically set for experiments in the area of what we call thermal fluid sciences. So that would be experiments in fluid mechanics, heat transfer, and thermodynamics. So there's a few examples of some of the equipment that we have to support that. Again, let me try to turn this camera around. Here we go. Here we have a wind tunnel. Basically is a high horsepower fan in there that pulls air through this test section. And inside that test section, we can get up to close to about 100-mile-an-hour winds. And then this apparatus attached at the outside of the test section allows you to be able to measure lift, drag, and moment force. And so there's a lot of different experiments that are used for flow analysis, lift and drag and wings, and so forth. There's a few other experiments in here that I'll highlight. We have here, if you can see, there's some piping going across the roof or the ceiling of this room. That's actually not part of the building. It's actually an experiment by looking at pipe flow and fluid flow in pipes and pressure drop and pump performance. We have here a thermal conductivity tester, which basically tests insulating materials. My PhD research was on developing wetsuits for Navy SEAL diving, and so we got the system when I started that allows you to test thermal properties of insulating materials, such as foam neoprene wetsuits, which is part of an experiment that we do for the course. And there's many other pieces of equipment that we have that support that lab. I'm not going to go through them all, but basically, again, they're all meant to be able to support the area of thermal fluid sciences, and then students are required to write up communications about the data that they collect in order to present the results. So that's it for here. We're going to go move on now to a different lab. We have several different spaces that we use to support different activities in the department. The next space that we're going to go to is what we call our materials testing lab. And there's another professor in our department who is going to present that space. And I'll go ahead and introduce him right now. So I'm going to turn the camera around. And this is Dr. Richards. Hi. And he is going to take some time to present to you. Actually, we're not going to go to the materials testing lab first.
We're going to first go and stop and look at our manufacturing lab, our growing capability and sort of advanced manufacturing technologies. Come on in. I've never done a live stream video off an iPhone before, so this is new experience for me, and I hope for you too. But let's come on in here and take a look at some of the things we're doing with additive manufacturing, or what you probably know as 3D printing. 3D printing has become an amazing technology for mechanical engineering. People use it for all kinds of things at their houses, we know that. But for mechanical engineers, it's greatly simplified some of the processes that we do. So we've added a number of 3D printing capabilities to our suite of manufacturing so that our students can get experience how to use this to do real engineering problems. So let me give an example here. Until 3D printing, if we wanted to make, say, a part of a turbocharger for an automobile engine, the only way we could do it was to cast and mill the actual metal parts. It was very expensive to actually try and change these or improve them. But with the advent of 3D printing, we can actually print the part in plastic and then check all the things like the fluid flow and its performance. And so what we do in this lab is we train our students, how do you use 3D printing to create parts that are prototypes? So for example, I'm showing this turbocharger part right here, and here's one of our students has just made a small pump impeller in the 3D printer. So the 3D printers that we have here in this particular lab cover a range of capabilities that we need for engineering problems. We have one printer that has a soluble support, so you can make parts, things like gears, and then melt that support out with steam, so you can actually make parts that move after you've done the fabrication. Then we have these two Mark IV printers where we can take things like carbon fibers and they're inserted into the matrix. So you can make a very strong components that you use in real engineering problems. So for example, some of these are the carbon fiber parts that we've made, and we put these together for an actual project. You're going to see this small engine running here in just a few minutes in the machine shop. But there was one part where I'm pointing the pencil right in the middle there, very small part, high precision part. All of our sophomore students make this as part of their lab, very time consuming to make 50 individual parts. So what we did is we actually fabricated a soft jaw for one of the computer controlled machining centers. And now you can see the parts that we made. This is the part I was pointing to. These get inserted into that jaw and then they can be machined in large numbers quickly to make these parts for that particular project. So it's an example of how we actually use 3D printing to accelerate the engineering process. We have other 3D printing capabilities here. Some are more workforce capabilities, like the ones you just saw where that impeller is being made. We've been able to do builds in that particular printer for periods of up to 5 days. So we can make very large parts for projects that our students are involved in making. So that's how we make some of these parts, but I want to also move on now to look at our materials testing lab. We just came from a lab where Dr. Barbie explained how we teach students to do tests on things like fluid flow and the drag over an airflow. We're going to now look at a place where we teach students how to make tests on actual materials. So let's walk down the hallway and we'll take a look at that.
As we walk, this is under construction. We have an area here where we're going to have a plasma cutter and also a couple welding stations. All new tech, all high quality, and giving our students great opportunities.
So before they manufacture some of those things, they have to learn about the materials that are actually be a part of the components they're making. So during the sophomore year, our students participate in the lab where we're now walking, and they actually make measurements on the strengths of different types of materials. Last year, we had some sophomore students. One of them was very interested in golf, and he was interested in the actual performance of golf balls and realized because what he was learning, he could actually compare the performance of different golf balls. So I want to be very careful not to do a product placement here. I've got my finger over the vendor name, but this is a golf ball, as you can tell, and you would never guess how many pounds we subjected this golf ball to. Probably I can't hear you responding, but I will tell you, in this material testing machine here, where you now see a yellow golf ball slightly squashed, all right? I'm now going to ask Dr. Barty to pan over to the control screen where we're actually measuring the golf ball you just saw at about 1,500 pounds of force on that golf ball. And you saw how it was deformed. We're going to let it out of there in just a second, and you'll see what happens. This golf ball I have in my hand, we put 4 tons on this golf ball. It was only about an inch wide after we squashed it, and we released it. It came back, and it looks almost the same. It's an interesting example of how you can discover things that you might not anticipate using some of the equipment we have for materials testing. Well, let's take a look and see how this particular golf ball did after it's been sitting there with 1,500 pounds of force on it. I'm going to actually release that right now. And look at that. It comes right back out. And it's actually only slightly smushed. So our students are able to carry out tests like this on ordinary products, on materials that we develop that are going to be used in engineering applications. That's what they do in this materials testing lab. I think we're going to move on to Dr. Klaus is going to take us on to the next stop.
That's right. Thank you so much, Gio. And let's move on to talk to a student who's involved with the Sae Baja Team. And our Baja Team is very active, and they're also linked with the Society of Automotive Engineers. So let's go. Hello. Hi there, Luke. You're on, Luke.
Hello, I'm Luke Johnson, and I'm a member of SAE, and part of the Grove City College chapter of Society of Automotive Engineers, SAE, which you may have heard of. They do a lot with manufacturing automobiles, and if you're interested in getting into the automotive engineering industry, SAE is the club to belong to. We participate in their collegiate design series, in which we race our in-house made Baja car across their various competitions all over the country. We love to make a lot of our own components in-house, including some of these suspension and transmission components. And if you're interested in getting involved in the shop at the school, joining Baja is a great way to do that, where you can get in here with lots of older students and gain some experience and hands-on, where you not only design something, but you also construct it and see if it works for yourself.
Great, Luke. Tell me a little bit about this year's competition and some changes.
Well, so far this year, SAE has changed the rules, and we now have to design four-wheel drive cars. So we are working on the senior design team to implement that, hopefully for this coming season, and hopefully we'll do well.
Great, Luke. Thank you so much. Well, we're in the machine shop, and why don't we talk a little bit about that? And you'll meet our next faculty member. This is Dr. Mark Archibald, and he's going to tell you a little bit about what I would call maybe the heart of our department, this machine shop. It's used so much for all kinds of things, from gaining experience for our students as sophomores, constructing and manufacturing components, as you just heard from Luke, and also supporting our research. So Dr. Archibald, tell us more.
Hi, good afternoon, and welcome to the Grove City College Engineering Machine Shop. We have a pretty well-equipped shop here. We actually have equipment in some other facilities as well, but this is the heart of our machining operation. So behind Dr. Klaus over here, we'll kind of walk you through some of the equipment. We have a wire electric discharge machine. This is a machine that can make very accurate cuts, used widely in tool and die manufacture. We keep that machine running very frequently. And we have some parts here that we can show you. This is a gear with an internal spline that has been machined to high precision using this machine. Let's take a look at some of the other equipment in the shop. We have a couple of manual lathes, an old one and newer one. Kind of the workhorse. We have a couple of manual knee mills, such as the Bridgeport that we see here. And those get a good bit of use. We also have computer numeric controlled machines. The Fadol is a computer numeric controlled milling machine. This is a 3-axis milling machine. And it also stays quite busy. We use it to make many parts. Currently, it's down for maintenance right now, but we expect it to be restored and back in service very soon. We have our CNC lathe here on the left. Again, another piece of equipment that's used extensively and oftentimes stays quite busy in the shop. Currently, if we look at the general setup of the shop, we are configuring right now for our sophomore lab. In our sophomore lab, we bring all of our students into the shop, give them an introduction to machine shop operation, make sure they can operate the machine safely, and while they're doing that, they work on a project. Here we have the current sophomore project. This is a small engine. It operates on the Stirling principle, so it's known as a Stirling engine. It runs off of a small alcohol burner, and the students fabricate and machine those parts, assemble the engine, and have it run. So you can see a nice example of that there. Also on the table are some additional parts that we make. I teach a course in programming the computer numeric controlled machine tools, and I actually have some of these parts every year. I do a different part for the final exam. So that was my final exam last January, and the salt and pepper shaker were the year before. We tried to do something fun and pretty. Some other parts we have that we have machined in the past. We have a pump, a senior design project from a number of years ago, but that was an interesting one. The students designed it. They designed the tooling for the casting. We had the part cast in aluminum. They machined it. They assembled it, and then we had some of those working in Latin America on a farm to provide water for irrigation for a farmer's crops, which is one of the things we really enjoy doing, those types of service-related projects here at Grove City College. So I hope you've enjoyed this brief tour of the machine shop, and I hope you have a wonderful day.
Thank you very much, Dr. Archibald. Our next explanation is going to be described by Dr. Barty.
All right, thank you. Our next stop, we're going to be heading over to a room where we're going to talk about our HPV club. HPV stands for Human Powered Vehicle. So in a way, it's similar to the Baja car, where but instead of building a vehicle, students build human powered vehicles for competition. So I'm going to go ahead. We're going to enter a room here where we have a student who's heavily involved in it. His name is Tim, and he'll go ahead and explain a little bit of some of the activity they do.
Hello, I'm Tim Mccloskey. I'm a senior. I'm also president of the Human Powered Vehicle Club. We're an organization on campus. We participate in the American Society of Mechanical Engineers, charged to build a human-powered vehicle and then take it to competition in the spring each year. So here's some examples of some of those. Here we have like a three-wheeled trike. And then over here we have a low racer, which is a two-wheeled bike. You can see it's some pretty weird-looking stuff that we managed to put together for the purpose of taking and competing in this competition. Basically, the idea is that you design something and you build it over the course of 2 semesters to showcase excellence of design and ultimately take that to a competition and a panel of judges, present it to them and show them why your design is worthy of the marketplace and what it can actually do. And in addition to presenting the bicycle to a panel of judges to present your design, you'll actually get to race them also, which is a phenomenal experience. There's 2 separate race events, the first of which being a drag race where vehicles go head to head to see which is the fastest in a straight line, basically. And then the second event is a grueling 2-hour endurance race, basically an obstacle course, going at high speeds, low speeds, uphill climbs, speed bumps, slalom of cones, split-second decision making. It's all designed to potentially break the vehicle, but also to see how well it functions in each of those different scenarios. Now, as far as the club goes, we're a group of about 15 mechanical engineers. We welcome anyone, but typically it's mostly mechanical engineers. And we are not bike enthusiasts per se. You know, most of us aren't. I have become a bike enthusiast through the club, but it certainly is most people aren't whenever they join. And it's more really a great way to get together with a bunch of students who are underclassmen, upperclassmen, and to work with professors to actually apply the stuff that you are working on in your classes in a practical sense, extracurricularly. And it tends to be really, really enjoyable. So I'd like to encourage you guys, whatever it be, whether it's this club, whether it's Baja, or being a shop assistant, or playing a sport or whatever, do something that gets you maybe out of the classroom and out of your homework and gets you doing some other things with your hands, some fun stuff, and working with other students. I don't think you'd regret that. So my best wishes.
Thank you very much.
Yeah.
All right, Tim, thanks. So we're nearing the end. We're not quite at the end yet, but we're going to go ahead and actually talk about research at this point, and following the following research, we're going to have Dr. Klaus and I are going to have some closing remarks and give you some time for questions. So right now, we're going to go ahead and start talking about some of the research that we do here at Grove City College. Our very own Dr. Anderson is going to talk to you about that. Now, he couldn't be here in person, and so like what Dr. Allison did for minors, Dr. Anderson recorded a video to show you guys, to highlight some of the research that some of the faculty in the department do. So Ethan, if you want to go ahead, you can go ahead and take control of the screen and play that video for us, please.
Hello, I'm Eric Anderson, a professor in the Department of Mechanical Engineering at Grove City College. I hope you're having a great visit. I'm here today to talk to you about undergraduate research opportunities at Grove City College, and specifically in the Department of Mechanical Engineering. So you might wonder, why undergraduate research? You might wonder what undergraduate research is. Well, undergraduate research is an opportunity for you to answer real-world questions while you're an undergraduate, to be involved in original research with a scientist. And here in the Mechanical Engineering program at Grove City College, we have research labs, and several of the professors are involved in original research and include students in that process. And one of the things that you do is you apply things that you learn in the classroom, which a lot of students say helps them to enjoy their work in the department more. And in fact, there's research that shows that students are more likely to stick with their major if they do research in their area. Graduate schools also expect you to have research experience if you're interested in going to grad school. And you may not know now whether you're interested in going to grad school, but someday you may be. And at Grove City, you'll have the opportunity to get that experience if you need it. Research and development jobs in industry are also looking for people who have the ability to do data analysis and data taking, and doing research helps you gain some of those skills. The other great thing about doing undergraduate research is you learn how to work professionally and with collaborators, and how to work on a team. You also get experience using state-of-the-art experimental equipment. And at Grove City, we've got some state-of-the-art labs where you can do things in fluid mechanics, in thermodynamics, in biomechanics, and I'll show you some examples of that later. One of the great things about doing research is you're part of a community of people, students and professors, and it's a great community to be part of. It's a lot of fun working together and enjoying doing really interesting work together. And you gain experience doing things like going to conferences and doing data analysis and getting out in the field and taking data. We also work with a lot of great collaborators at Grove City College. We've got relationships with organizations like Woods Hole Oceanographic Institution, Harvard University, New Jersey Institute of Technology, SeaWorld, Georgia Tech, University of Michigan, Oni Rees, a technical university in France, and many more that I don't have time to mention. My area of research is biofluid dynamics, so I'm going to show you some of the work that I do, and I'm going to mention some of the work that is done by other scientists at Grove City in the Mechanical Engineering Department. So one of the things that my lab does is tries to answer some big questions in biology. Some of these questions are related to resource management, and so some of the work that I do, like developing whale tags, is for the purpose of helping to manage those resources and protect those organisms. Some of the research I also do is related to biologically inspired designs for example, for efficient vehicles. You can see some pictures here of some of the data taking that we did at SeaWorld, looking at the sucker of a remora fish to design a suction cup for whale tags that hold on longer than standard suction cups. And we've had some work published recently on that topic. We also do a little bit of work in biologically inspired processes and logistics. Another one of the projects in my lab is looking at how small organisms respond to turbulence. This gives us an idea about the possibilities of their distribution and the health of their populations. These are oyster larvae that you're looking at right here. This is a multi-million-dollar industry, part of the food industry, and important to coastal economies. On the right, you can see the Turbulence Tank, which was built by Grove City College seniors in the mechanical engineering department. And this device was featured on the oceanographic website as my group was using it to do some of the research at that institution. We also have a faculty member, Dr. Eric Barty, who I think you know by this time, who does some work in the food industry in the area of thermodynamics. In particular, his work is related to something called electrohydrodynamic drying. This is using high voltage electric fields to increase energy efficiency in food drying. This is in collaboration with Oni Rees, which I mentioned before, which is a technical university in Nantes, France. And again, all of these things that I'm talking about, all these research labs, there are opportunities in them to work with these professors for our students. Human biomechanics is another field that we have faculty members working in the mechanical engineering program. Dr. Gio Richards is working on a team that is looking at acoustic signatures of footfall in running to assess athletic condition and injury recovery. And Grove City College has a human performance lab with all kinds of devices that can be used to look at athletic ability. And this work is aimed at helping those athletes and also helping coaches get information they need about athletic condition and injury. And very recently, we also had a group of students that worked on the NASA Undergraduate Design Challenge, looking at the possibilities in electric flight. And this is something that's just started up at the school, and we've also got a club on campus that's for people who are interested in aerodynamics and aerospace engineering. So I hope you enjoyed that introduction to the possibilities of research at Grove City College in the mechanical engineering department. The best way to get involved is to talk to your advisor when you get here. I hope that you have a great day and enjoy your visit. Thank you.
Okay, perfect. We are going to have a Q&A session now, and we'll explain a little bit about that. But before we actually get into that, we are going to let you know that it's recorded. Are we part of it? Okay, all right. So it's recorded, and that you can view this at any time. And we're going to actually store the video in a little, up here at the top, tab. We'll create a tab called Videos, and you'll be able to see it. We'll also have other videos that we will have throughout the remainder year and next semester that might be helpful to you to actually hear and see. Let me also tell you a couple other things that you can see at this site, because this site you'll be able to access under Files. We have a variety of different folders for you. We recommend you read the first README document that's found in that first folder. And then there's other folders that you can see, some about prospective student documents, some about status sheets, many other things. If you're in 10th grade, you may want, or even 9th grade, you might want to take a look at 10th grade suggestion information. Or maybe you're in 11th, 12th, you want to go there. What that talks a little bit about are some of the dual enrollment opportunities that you could take advantage of. Finally, the master's program is brand new here at Grove City College. It's beginning within the year or two, and you can learn about that. So let me also show you that over here on the side here, you'll see there's this chat option. This chat option permits you to have private conversations with individuals. So you can actually, when you click on it, you can actually type in up here that you want to talk to Dr. Barty or myself. Just type in our last name. There's another also realm that you can do, in this general category here, you can actually find there's a dialog box at the bottom that you can type in information, but that will be made visible to everybody. So let's talk a little bit about how we're going to do questions. So the process we're going to do today, I hope it works, is that you can either open your mic and ask a question, or you can click open this conversation chat and you can put some questions in here. So I'd like to open it up to you all. Maybe you have some questions. Maybe we can help you out with.
Yeah, and we're available to answer any questions you guys might have. And just as a reminder, as Dr. Klaus mentioned, we want to keep contact with you guys throughout the year as you guys start your quest trying to figure out where you want to go for school. You have more questions that come up about Grove City College. This can be our medium of communication. So we're both connected to this as well as all of you past this event, and we'd be happy to keep contact with you. But at this point, we would love to answer any questions. So if you actually want to ask live, feel free to go ahead and unmute your mic and you can verbally ask us a question, or as Dr. Klaus mentioned, you can go ahead and type it into the chat here. So we'll take a moment in silence just to kind of get an idea of give you guys an opportunity to go ahead and ask. Dr. Klaus, I think I have a question.
Oh, what is that, sir?
I know that a while since I went to school, I won't say how long, but I remember I had some classes I wanted to transfer, and I was curious about some of the AP courses that I was taking at the time. Were they accepted or not? So how does that work here?
Sure. A lot of students come in with AP credits, and if you receive a certain score on the AP exam, then you'll be able to get credit for Calc 1 and sometimes Calc 2 and even up to Calc 3. Other students who've taken AP Physics receive credit for Physics 1 and even sometimes Physics 2, depending upon how far their program in their high school goes. So that's sort of a little bit about AP credits. You can also get them in a few other classes, but most of those will apply for general elective credits.
Too, that we didn't mention throughout this tour is that we were asked in the past about study abroad opportunities. Right? So we do have some study abroad opportunities here at the college. Significant opportunities in 2-week short-term travel courses, as well as some summer programs. And we historically here had a mechanical engineering study abroad program that is now being reevaluated. And so information about what that might look like in the future is forthcoming. So stay tuned for what that might look like in a future time. So yeah, anybody have any questions that we can answer? We'll go ahead and wait another minute. If not, we'll make a few closing remarks. Oh, I see that there are a few people who are indicating a raised hand. So we'll go ahead and Jacob Wong, I see your hand up. If you want to go ahead and unmute your mic, you can go ahead and ask a question.
Okay, so my question is, you talked about AP courses. How about dual enrollment courses? Can you transfer those credits?
Good question. Good question. Sometimes they can be transferred. It depends on what college they are in conjunction with. Other times they do not transfer. It depends also on whether it's being taught by a high school teacher versus a faculty member at a college or university. It's done on a 1-by-1 basis, though.
Does that answer your question, Jacob?
Yeah, and also, when can we find out if we can transfer them, the credits?
As soon as you apply, then you can also then reach out to the registrar's office, and then you will be able to give them the information, and they will then send it out to the department chairs so they can take a look and evaluate that.
Yes, okay, thank you.
You're welcome. Okay, next, Abigail Hopper. I see that you have a question. You can go ahead and unmute your mic and ask your question, please.
How high do you need to get on your SATs to get a scholarship academically?
We do not give any scholarships directly based on an SAT score.
There are a variety of scholarships that are offered. Some are associated with our Trustees Scholars Program, which are quite nice. Those are very competitive. So that's the best I can answer for that. I know there's also some engineering scholarships for freshmen. It's something that when you apply, then you could also ask the financial office about some information about those.
Thank you for your question, Abigail. Anybody else? Does anybody else have any questions they'd like to ask us? Sam, I see you have your hand up. Go ahead and unmute your mic and go ahead and ask your question, please. Sam, we can't quite hear you yet, buddy. Sam, I think you're still muted. If you're having a problem with your microphone, you can go ahead and type your question in the chat. I'm sorry, Sam, we're still having a hard time hearing you. What we'll do is that I'll circle back to you. Okay, we're going to move on to another person, and Sam, I will come back to you in the hopes that you can figure out how to connect either through the chat or with your microphone. So we have another question from, is it Alea Wellman?
Yeah, Alea. What does like the biomedical engineering program look like at Grove City? Like, would that be more like on the mechanical engineering side, or like more on the biology? Like, what departments would you be working with?
Okay, we actually did not have a biomedical engineering program. However, we do have a lot of projects that have that kind of emphasis, and many of our courses also overlap with what you would take as a biomechanical engineer. Such classes as our biomechanics class taught by Dr. Anderson, who was introduced at the research video. And he also does obviously studies with aquatic life and motion of aquatic life, which is obviously biomechanics related. I myself have a PhD in biomedical engineering. And so I've had different projects through the years that is associated with that. And we could also tailor by choosing your electives wisely, we could tailor your program to be more of a biomedical emphasis, if you want to call it that. I'll let you know now that from our experience by looking at biomedical engineering programs, because I have experienced it myself, in most cases, getting an undergraduate degree in mechanical engineering is really a wise way to go. We also you can do it in chemical engineering, electrical engineering. Those would be three basic engineerings that go very nicely into biomedical engineering. In many locations, if you want a true biomedical engineering job, you actually will need a master's or a PhD. So our suggestion is that you get that basic mechanical engineering degree and then go for that next degree in biomedical engineering and do your emphasis that way. And also what that provides for you is that as you look at your job market, if, for example, suddenly there's a problem in the sort of bio field and the job market offerings are shrinking, you still have that full-fledged mechanical engineering degree you can go back on, which will open up lots of avenues for jobs. That's just my sort of advice.
Okay, thank you.
Certainly.
Yeah, I'll add a little bit to what Dr. Klaus is talking about. Hearing your question reminded me when I was trying to figure out what I wanted to do. And with engineering, there are obviously so many different fields that we hear of, right? And some fields are very specific, and some fields are more widespread. Mechanical engineering is one of what we would say the major engineering fields. And within mechanical engineering, there's many subfields, of which biomechanical engineering is one of them. So when we look at an undergraduate experience, meaning a place to go to get your bachelor's in mechanical of engineering, my advice to students that visit with me has always been, when you're 17, 18 years old looking to go into college, the best thing to do is to cast your net as wide as possible. Meaning you go into an engineering discipline that not only covers what you're interested in, such as biomechanical engineering like you, but also something that expands wider than that. Because as you go through your 4 years, it's very possible your interests could change. With a mechanical engineering degree, it's so versatile that you can get involved in so many different areas. When I was a freshman in mechanical engineering, I didn't realize I'd be in an area called thermal fluid sciences. I didn't actually like it at the time.
And then when I finished, I ended up going into biomechanics research and getting a master's degree in it, and then a PhD in physiology along with mechanical engineering combined. And so all that to say is mechanical engineering is a great discipline to get into in the sense that it casts a net so wide that it opens up a lot of opportunities at the end, of which biomechanical engineering is one of them. We just had a graduate, female graduate this past year that graduated and ended up going into the field. And we have countless examples of others that have done the same. So I hope that answers your question.
Yeah, it does. Thank you.
Yeah, you're welcome. I see some other questions. I'd like to circle back to Sam. Sam, have you been able to work out the technology issue that we were having earlier?
Yes, I did. I just, I wanted to ask about biomedical engineering, and you just answered my question, so thank you.
You're welcome. No problem. All right. I see we have some other questions here.
Jackson, I think I saw Jackson pop up with a question.
Yeah, you talked about how mechanical engineering can go a lot of different places, and I'm interested in both mechanical and electrical engineering. So I was wondering, say I pick one of those fields freshman year, if I were to change my mind, how difficult would it be to change classes to the other major?
Great question, Jackson. I would recommend for you to actually apply for mechanical engineering, because mechanical engineering right now is very, very, very popular. And so you'll want to make sure you're admitted into it. We can't guarantee that if you come here as an electrical that you could change majors into it, but you will be able to change majors out of it and go into electrical engineering. Your first year is very similar between mechanical and electrical, and so therefore you won't be losing out or getting delayed if you choose to go first mechanical and then say, "Ooh, I really like the electrical." And that we've had a number of students be able to do that pretty successfully. Is that helpful, Jackson?
That is extremely helpful. Thank you very much.
Sure. Okay, some more hands.
So, Jackson, we just answered your question. Alea, you still have your hand up. Did you have another question, or okay? Sam, you still had your hand up. Did you have another question?
Can you guys hear me?
I can hear you just fine. Go ahead.
Okay, great. So which sport in the, I guess, mechanical engineering area has the highest % of people enrolled?
Good question.
Well, that is a very good question. However, Sam, it changes year to year. I can tell you safely that we have had athletes in every sport, men and women, and they have been able to successfully venture the waters of mechanical engineering. We've had people on the football team, we've had people in the swim team, we've had people on the women's volleyball, we've had also basketball and softball and baseball. I'm forgetting probably some of them, but we have sports people on every different team. And let me tell you, the team coaches are extremely supportive of your academics. And so we really do a great partnership with them. And I think that no matter what, you'll find somebody who's always a mechanical on that team.
I'll add to that too, that our student athletes tend to be very disciplined. So I've had, and I'm not saying you guys assume this, but I've had some people in the past assume, can I do engineering in a sport? Is it even possible? Will I pass if I have to spend the dedicated time I need for the sport? And our student athletes tend to be disciplined, and their coaches, as Dr. Klaus mentioned, are very sensitive to the fact that you're here for an education first and the sport second. And they are extremely supportive when exams are coming around, and we work with the coaches to make sure that students can make up work when necessary. And so I'd say our student athletes have been, I've been here 15 years, have been most of the time near the top of the top performers in our department. So,
Leah, do you have another question?
Yeah, do you guys offer any programs or maybe even financial aid for coming from out of state to visit Grove City? Or
you mean, do we offer financial assistance for prospective students to come visit campus from out of state?
Yes.
I'm not aware of anything like that. That would be a question you'll need to ask admissions. I'm sorry.
Okay, that's fine.
One thing I do know that admissions does, and Ethan, who has been our admissions rep here, can confirm that for me maybe, that they do have now with COVID, there's been a new system in place for virtual visits. Is that correct, Ethan? Yes, okay. So there are virtual visit options. If for some reason you're at you're located somewhere far where it might be cost prohibitive for you to come visit, we would love to be able to host a visit. And even any of us faculty would sit one-on-one with you as we are now with a private conversation over Teams or any other medium to talk to you. And I've walked around with my phone just like we did for this visit to give you a visit at campus. And so we can do our best, although we might not be able to give financial assistance to get you here to visit, at least not that I'm aware of. There might be something, but I don't think so. But we would definitely like to host you virtually.
Also, it's pretty easy to come into one of our classrooms. All of us are doing it both online and live in the classroom. So, for example, all of my classes are done that way, and I could easily add you in just to sit in to see what a class looks like for somebody here.
We actually teach our classes as you are connected with us right now through Teams. This is how we teach our classes. We simulcast our screen, and it's basically voice over screen capture. And we've had students, for example, that go in isolation because of a COVID issue, are connected to class like this, and then when their issue is when they're clear, they come back to the classroom. So
it works really well.
Yeah, it does work pretty well. So if any of you are also interested in joining a class, yeah, like Dr. Klaus said, we'd be more than happy to get you guys connected for that.
Is that helpful, Elena?
Yeah, thank you.
Thank
All
you.
right.
How about you, Jacob? Do you have a question?
Yes, my question is, are there other classes required other than the core classes for mechanical engineering, like such as like humanities or literature?
What do you mean wired? Do you mean like online classes that you could sit in?
I mean for like like a freshman, are there other courses required other than like the core mechanical engineering classes?
So are you asking if there are other classes that are where technology like this is used to help facilitate both remote and in-person people at the same time?
Not quite. I was thinking more of like humanities or writing.
All right, hang on a second. Yeah.
Yeah.
Let's see if instead of the video, let us actually can you control it so that you can get it back to the Teams website
Yeah. So
yes, I'll show you where some information, Jacob, is that you can look all about this.
Okay, thank you.
Over. Okay, Dr. Klaus is going to go ahead and answer your question.
All right, Jacob, can you see the screen now?
Yep.
Perfect. Under this Files tab, okay, you'll see this folder entitled Status Sheets. And under that, when you open it up, you'll see 3 different status sheets. One, if you just want to do straight mechanical engineering. Another, if you want to do the chemical engineering minor, and another if you want to do mechanical with the robo minor or robotics minor. Let's just open up this first one, which is the general mechanical engineering option. Okay, let me also get this off of the screen here. Oh, why is that up there? Okay, well, if you look at this particular document here, what did you say? I've been trying to, but it won't. Oh, okay, there we go. Thank you. Okay, Jacob, can we zoom in? Perfect. Now, if you, oops, wow.
That didn't do what I wanted to do.
Oh, well, as you see, technology is not always a friend, at least not for me.
Right.
Okay, well, let's look on here.
Yeah.
Let's look on here. If you look on here, you can see your freshman year, that first sort of 2 values or boxes areas. You'll not only take in chemistry, and math 161 happens to be Cap 1, and you'll also be doing engineering graphics, which is our MECI 107, and our solid modeling, which is 109. But you're also going to be taking a humanities class 102, which is associated with our general education curriculum here that every student that goes through and graduates has to take. If you look at the second semester of that, you'll see that you'll be taking a writing class, Writing 101. And so all of these pieces throughout, if you look at other pieces, you'll see, for example, your sophomore year, we recommend you taking what's called an SSFT course. That stands for Science, Faith, and Technology. You'll take that class. You're going to be doing another HUMA class your second semester of sophomore year. So you'll see scattered throughout those 4 years, there are humanities classes, writing classes, social science classes, and things like that that are part of our general education curriculum. Is that satisfactory, Jacob?
Yes, that answers my question. Thank you.
Perfect. All right. So let's come back here. All right, David, looks like you have a question. David, are you there? Oops.
You might want to mute your,
Yes, I am here.
Perfect.
All right, go ahead.
So you were talking about that Microsoft Teams thing that you were just on that page.
Yes.
Are we able to currently access that, or is it as soon as we're accepted, or are we never able to access that?
Yeah, you can access that right now. So this team, this group that we're a part of, that as we're talking in right now, won't end when this video is over, when we're done talking. You'll still have access to this. Right? And as you have access to this, you can actually access all those documents that Dr. Klaus was mentioning. And you can also further conversation with us, right? So you can actually come back to this group, find one of us, and ask us a question, schedule a meeting if you want to talk to us to get some more info. So this actually, we consider this event sort of a launching point for us to continue to be in contact as you guys explore different schools, and you come back with more questions for us as time goes on. And as you go through your application process, you'll have direct contact with us as faculty to answer questions you have.
Yeah, so you can just enter either through the app or the website, whichever way you gained access to this.
Thank you so much.
You're welcome. Sam, I still see you have your hand up. Did you have another question?
Yeah, so you guys mentioned something about materials engineering very briefly earlier. Do you plan on expanding that program at all in the future?
What we introduced you to was a lab that's used for materials testing. So when I was mentioning earlier how mechanical engineering has sort of a large wingspan that covers a lot of different areas, materials is one of them. So we have courses in place that teach you the basics behind that, materials and mechanics of solids. And in those experiences too, we have added another class that includes experimentation in that area where you test material, you look at material properties such as tensile strength, compression, impact strength, fatigue strength, hardness, and things of that sort. So that's what that lab was meant to do. So it's not really necessarily a separate program in materials engineering, but it's the topic of materials and mechanics of solids integrated into the mechanical engineering curriculum.
Right. And in addition, however, if you really do have an interest in the materials side of things, then you could probably pair yourself up with some faculty members to do some individual research in those areas so that you can delve even deeper.
All right, thank you.
No problem. Any other questions? All right. Well, you guys have been great. This is, again, our first experience in this. Look, we have another.
Oh, we have a hand. Autumn.
Autumn, go ahead.
Hi, sorry. You mentioned mechanical engineering as being a very general degree. Is electrical engineering as general of a degree, or is it more narrowed in your opinion?
Sure, I'll do my best to answer that. I wouldn't say that engineering is a general degree. I'd say it's a very large spread discipline. So because I make that specification because there are some places that offer degrees in engineering, which would be a general engineering degree. What we have here specifically in mechanical engineering, which happens to be in itself a big widespread field. So to answer your question, is electrical engineering a specific field or a widespread field? I would say it's a little bit more specific than mechanical engineering, although it does cover quite a range of topics. Maybe Dr. Klaus can add to that.
I would say there's three basic wide-ranged engineerings: mechanical, chemical, and electrical. They each have their own special realm, and you can go many different routes outside of those and diverting outward. So I wouldn't say that electrical is more confining. It's just a totally different area, though, than mechanical.
Okay, sweet. Thank you.
You're welcome, Adam.
Anybody else? Any other questions? Okay. So.
Well, I hope you guys learned some things about Grove City Mechanical Engineering. We do thank you for your patience because this is a new endeavor, this route. We also hope that it wasn't too painful. But if you do have any questions, please make sure you interact with us and take a look at what's available at that team's website. We do want to be able to answer questions.
Okay. Like I said, this video will be saved. So if any of you wanted to watch the video again or aspects of it or share it with other people, it'll be available within a few hours after we end. So thanks again. We're going to go ahead and terminate this video. And thank you again for participating.
Bye-bye.
Bye.